It's still January sale time. That means you can subscribe to New Scientist for just £12.50. Our January sale includes special offers on digital packages and print-only packages. For print-only, you can subscribe for just £12.50 for 6 issues, and for digital, it's £16.25.
Digital subscribers get unlimited access to everything on newscientist.com. They get unrestricted access to the New Scientist app, including our Essential Guide series. There's free online events, our weekly Editor's Highlights newsletter, and there's access to free accredited courses from the New Scientist Academy.
Go to newscientist.com/JanSale2023 to snap up this bargain. Unleash your curiosity. Join the journey to discover the frontiers of science with New Scientist Weekly. I'm your host, Rowan Hooper, and welcome to the show.
And I'm Benny Sarche. Welcome to the show.
Matt, did you notice anything different about that tagline this week?
No. Is there something I should be noticing?
Well, did it sound artificially generated by ChatGPT? Because that's what it was. I asked ChatGPT, I nearly said her for some awful reason. I asked ChatGPT to generate a compelling tagline to our podcast, and that was it.
Well, I was compelled, so
just
well
as
done.
cheesy as the normal one.
This week, we're joined by New Scientist journalists Matt Sparks, Abby Beale, and Carmela Padovic-Callahan. Hello, welcome all.
Hello.
Coming up on the show this week, we've got an asteroid mining launch, and we've got news of a green comet approaching Earth for the first time in 50,000 years.
We're also hearing about another latest extraordinary advance made by AI. This time, an artificial intelligence has designed and made new proteins with antibiotic properties. And we also have something you didn't know about chimps for our Life Form of the Week segment. All that coming up, but first, it's 2023 and we're hearing that water companies are still using an ancient technique called dowsing that was banned by the Catholic Church back in 1518 as occultism. Matt, what's going on?
So there was an investigation back in 2017 which found that 10 out of 12 water companies were still regularly using water dowsing to detect leaks. At the time, this attracted a lot of criticism by academics who said that regulators should really step in and stop what is basically the practice of witchcraft. 5 years later, we decided to see if things had moved on. So we asked all of the 19 UK water companies if their engineers were still dowsing. Yorkshire Water, South Staffs Water ignored us, and 15 other companies quickly dismissed the idea. But surprisingly, 2 companies, Thames Water and Severn Trent Water, admitted that they still do douse. Thames Water even lined up an interview for us with one of their engineers who told us that it definitely works and that he's used it to find plenty of leaks over the years.
Matt, Thames Water is my supplier. Can they come round and get rid of a ghost that I've got in the attic?
I imagine that's one of the services they offer, yeah.
Fantastic, yeah.
So dowsing has been completely scientifically discredited, hasn't it? But can you remind me what it actually involves?
Yeah, so the idea is that you hold these 2 rods, which the Thames water engineer told us that they don't get supplied. They have to make them themselves or buy them online. And you just watch for tiny movements. So you walk around near where the suspected leak is. And once you're over the right spot, the rods cross. Now, this engineer, he said he was pretty skeptical when he first saw it, when he first joined the company, but he's come to believe in it and that the practice is widely used across London and the whole area that Thames Water serves. You know, as for what's actually happening, who knows? It's possible that people are just ignoring the times that it doesn't work and focusing on and remembering the times that it does, you know, subconsciously. And some people have pointed out on Twitter that Thames Water might just have so many leaks that you can arbitrarily dig a hole anywhere and find one.
So when, you know, in theory, it's working in inverted commas and the rods cross, what's happening there? What's causing that movement? Is there a theory?
So we didn't hear any working theory from the people who actually use dowsing, but Christopher French at Goldsmiths, he told me that regardless of what people might say, the real reason is something called the idiomotor effect, which he told me is just a posh way of saying that they're moving the dowsing rods without realising it. So unconscious muscular movements are the cause. And it's the same phenomenon that makes Ouija boards spell out messages.
But did you do this when you were a kid? Make dowsing rods? You get like a bit of coat hanger and bend it into an L shape, right? And then you get the outside of a biro and poke the wire through there and then hold the biro kind of casing, the idea then is that the wires will move, but without you being able to move it because they're inside the casing of the biro. So that's how I tested it and dismissed it as a child.
I think that's how the engineers are making their own. I don't think it's any more advanced than that.
All right, I could get a job at Thames Water. Is there any way this could work?
Yeah, there is, but not in the way that people claim. So Richard Wiseman at the University of Hertfordshire, he told me that there was an interesting experiment where people were asked questions that they claimed not to know the answers to. And they were asked both verbally and by watching a pendulum where swings in one axis were interpreted as a no and swings in the other as a yes. And they were actually marginally more accurate when reporting from the pendulum, which suggests that it could be serving as a way to access some sort of subconscious knowledge using that same ideomotor effect. Wiseman says it's possible that dowsing works in a similar way. Maybe you're picking up on subconscious cues, like if you're very experienced in finding leaks, maybe you notice certain types of vegetation growing in one area or the health of that vegetation. And you're finding leaks with the rods, but the rods are only sort of revealing your subconscious knowledge. All we really know is that in laboratory conditions, there's no evidence that dowsing can actually find water.
Right, it's life form of the week time, and Rowan, not for the first time and probably not the last time, I think we've got chimps.
We have got chimps. Actually, this could almost be a sci-fi alert because I want to talk about Planet of the Apes first. So in those movies, and all of the movies, so the old ones in the 60s with Charlton Heston, and then the ones with Andy Serkis, and then there's new ones being made again now by Disney. And in all of these, there's something very unusual about the chimps. And can you guess what it is?
Is it that they're talking?
No, it's not that. It's their eyes. Now, all of those movies, the eyes of the apes have got the whites round the iris, and that's called the sclera.
Is that why it's always so creepy? I've sort of always found the eyes a bit odd in these films.
Well, yeah, it is, because they look very human, don't they? It makes them look human. That's why they've put them in the movies. And, a few people have moaned about that. A few biologists have said, chimps don't have the sclera. But that's an assumption, because it turns out that they do have them.
Right, so we just didn't know all this time?
Well, yeah, it just seems to be one of these things we assumed was unique to humans and didn't properly check. And this has just now been done in the wild, at least it's been done. And so a team's looked at 230 wild chimps in Kibale National Park in Uganda. And it turns out that many do have this white or light sclera, about 15% of them. And some have very prominent whites around their eyes, very similar to human eyes. And I'll post a photo because it really is quite weird and spooky looking.
So how has it taken this long for us to actually notice this?
Yeah, I asked the guy this, and he said that it's just that we assumed it was something unique to us and no one had actually checked. And other things that they found is that the sclera gets darker with age. So they found that 50% of newborn chimps have this white sclera, white around the eyes, and then it gets darker within the first year. And then even other mammals have it. And that's another thing being overlooked. So, we've been completely blinded to that because we think it's just unique to humans.
I guess it's not that surprising with chimps being such close relatives of ours. But is there an idea about why they and us have whites of our eyes? What do we use them for?
Yeah, I mean, the idea, the main hypothesis is that it really helps with subtle communication and cues to each other and invoking cooperation between groups and people. And that's probably still the case. And we know that chimps have got very complex and subtle communication. So it turns out that light sclera might also be more prevalent in gorillas, and it's probably the same in bonobos too. Time for a break. New Scientist is launching a new online event series called The Greatest Physics Experiments in the World.
Yes, the first talk in the series is called Secrets of the Large Hadron Collider. You can join particle physicist Clara Nellis, part of the ATLAS experiment at the LHC, the world's largest and highest energy particle collider, for a deep dive into the past, present and future of this incredible facility.
This online talk takes place on Tuesday the 7th of February from 6 p.m. GMT or 1 p.m. Eastern Time. And for more information and to book tickets, visit newscientist.com/LHC.
We're back, And it seems like every day some AI manages to master a new task. Certainly at the moment, they've been coming really thick and fast. And as you heard at the start of the show, they're even writing the taglines for our podcast now. But now we're talking about an AI that seems to be a pretty good synthetic biologist. So we've spoken about AlphaFold before, which can predict protein structure. And now, Carmela, there's a different AI that can design proteins from scratch.
Right. So there's an AI called ProGen from Salesforce Research in California, and it was able to design millions of proteins, many of which are nothing like those you usually find in nature. And when the researchers actually synthesized them in the lab and put them into living cells, they found that they're functional. So they participate in chemical reactions instead of just sort of like lying there.
I'm sorry to be so shallow, but if it's a really cool AI company, why have they called themselves Salesforce Research? Sounds like a marketing firm.
They have no idea, but they do a lot of like very cool AI stuff. So maybe you
They need
should
to be
write to them.
rebranded. Yeah.
So that's aside. It sounds like a really impressive feat. But what does it actually mean? The ProGen designs proteins from scratch. What's the starting material or ingredients that it uses?
Right. So ProGen is based on these AIs that are usually used to read a lot of text and then write their own. So you would feed a bunch of literature of some sort into an AI, and then it would, write grammatical, semantic sentences that make sense, and you could tell it like what kind of topics you wanted to write about and in what style. So here, instead of literature, what they fed into the AI were sequences of amino acids, which is what proteins are made of, and the AI learned sort of the grammar and the syntax of how amino acids combine into proteins, just like it would have learned how words combine into sentences. And instead of specifying the style of writing you wanted it to do, the researchers could focus the AI on some specific protein function or protein family.
So, I
That's
mean,
amazing, isn't
it's
it?
amazing, yeah, just to use amino acids like words to create new
Yeah.
functional proteins in theory. But then, of course, the big question is, do they work as proteins, and how did they then go on to test that?
Right. So they ended up with like millions of them, and they had to kind of narrow down the testing. So they focused on a family of proteins that are similar to proteins that have naturally evolved to kill bacteria in saliva, tears, and in egg whites. So there was a clear metric. If the AI generated a protein that could also kill bacteria, then clearly it worked. They did not synthesize all million of them or however many they had. They chose about 100. Out of those 100, about 66 had sort of high chemical activity when they put them into cells. And then they narrowed it down even more and found that there were two in particular that could basically demolish an E. coli bacterium, just like naturally evolved proteins.
That's amazing. So they're starting with millions, and then they're ending up at two. Is that better than what we'd expect, sort of by chance?
Yeah, so it seems like very small numbers, but usually to engineer a protein to do something you want it to do, you would start with a protein that exists already, and then you try to make a small mutation, and then you would try it again and make another small mutation, then another small mutation. So you stay very close to what exists, and you still have to hope for the best with your like accumulating small changes. The AI can do all of that at once, and it can do big changes. So some of the proteins that this AI generated were between 30 and 70% different than any existing protein. So when I talked to the researchers, they felt very much that, given this like large parameter space for the AI, choosing just 100 and finding that two of them work really well was actually quite surprising. They didn't expect that any of them would do anything other than sort of like be stable on this very first attempt.
So because it's such a different method to making just those kind of incremental tweaks that we would do experimentally, a human in the lab, is it fair to say this is kind of going to let us develop and invent proteins that we'd otherwise have to wait for a really long time to sort of see them appear naturally in evolution?
Yeah, I think if you wanted to be bold, you could say that this is sort of a shortcut to evolution. You sort of don't have to wait for some radically new sequence of amino acids to just pop up in nature over time. The AI will just give a bunch of them to you, which also means that if you're looking to make new drugs, this gives you so many more options than what you may come up with through more traditional methods.
It's really encouraging, isn't it? Because, we've written about the antimicrobial resistance crisis quite a lot. And like in 2019, 1.3 million people died because of that, because they were infected by something that was resistant to antibiotics, and that's more than get killed by malaria or AIDS. So it is a real crisis. I wondered how soon it might be before we go from these proteins, bacteria killing proteins, to actual antibiotics.
Yeah, I think quite a while, because even if you have this like remarkable number of proteins to choose from, and some of them are things that we may have not thought of to try before, this sort of testing and turning things into drugs and seeing what it does in an actual human, like that part is still done traditionally, and it will take a long time to sort of go through.
Okay, I want to talk about asteroid mining this week, which we sometimes do talk about, I know, but there is some actual news. So there's a company called AstroForge. It's a satellite construction company, and it's just announced that it's made a CubeSat that it will launch to space in April to test asteroid mining technology. And later in the year, it's going to send a larger spacecraft that will actually go to a near-Earth asteroid and collect data about the composition of that asteroid, including the presence of platinum and platinum group metals on it.
You have to excuse me for sounding a little bit skeptical about asteroid mining.
Yeah, I'll take that skepticism, but I just wanted to talk about these companies. So the AstroForge has outsourced the CubeSat to be built by a UK company called Orb Astro, and this is the one that's going to go up on a SpaceX rocket, and it is quite a cool bit of kit. What it's doing is taking some material with it in the payload, and once it's in space, it's going to vaporize this asteroid-like material and try and sort out metals from other constituents as if it had gone mining in space. And that second mission, which is also by the Orb Astro company, is going to do this flyby around an asteroid they've got in mind to see if it's an M-type asteroid, which M stands for metal, and that's going to be a 2-year mission to get up there.
So quite a long-term game then, isn't it?
It is. Oh, it's a really long-term game, and that's what I wanted to talk to them about, because AstroForge have raised $13 million in seed funding, but you can imagine how much they're going to need to get anywhere near mining an asteroid. Like, this is just to fly by it. Think about to land on one. There's a NASA mission going that we've reported on that I went to visit called Psyche. That's going to an asteroid called Psyche, a metal asteroid. NASA says the total cost of that mission is $985 million, so nearly $1 billion for that. That does include the rocket, but even so, that's just to land on an asteroid, not to mine it and then bring it back to Earth. So the cost of doing this is going to be, I nearly said astronomical, but yeah, it's going to be a lot. So yeah, you've got to ask why they're doing it when it's, more cost effective just to dig a hole in the ground here and get your metals.
So is this a bit like people like Jeff Bezos saying they want to put heavy industry on the moon to relieve pressure on Earth and be better for the environments back home?
Well, I wondered that as well. So, and I hadn't heard any asteroid company make that claim. So I reached out to them, the people at AstroForge, and the co-founder, Jose Acane, got back to me. They say that the foundations for a space-based economy are now being laid out because this company's pursuing, building commercial space stations and servicing in orbit and manufacturing. But he does say there's a long way to go. But here's what he says about, their ecological aims.
Our plan is to return the resources back to Earth, where there's not only a demand that exists today, but we're doing it in a way that's cleaner and more sustainable to further prevent damage to our planet. With a significantly lower cost to access space in a burgeoning satellite bus market, it is now cost-effective to bring highly limited resources like the platinum group metals back to Earth.
So they are making the claim that they're doing it for ecological purposes. So it is a long-term game.
Now, we're staying with space, but we're moving on to comets rather than asteroids. Abby, we're currently being visited by a really unusual comet, aren't we? But first, can you just tell us what the difference is between the two?
Yeah, of course. So the main difference is where they come from and what they're made of. So asteroids mostly come from the asteroid belt between Mars and Jupiter, and they're made mostly of rock and metals, like we've talked about. Comets come from much further away from the sun, so they contain rock and dust as well, but also lots of ice. So what happens is when they come near the sun, the ice heats up and the dust also vaporizes. So the ice turns straight to gas in a process called sublimation. that's what causes these comets to have their famous tails. So this comet that we're talking about now is called Comet C 2022 E3, very catchy, and it's a long period comet. So it comes from really far away in a place called the Oort cloud, and it takes tens of thousands of years to do one orbit of the sun. In this case, this one is 50,000 years.
And the Oort cloud, what's that? It sounds very cold.
Yeah. So the Oort cloud is a hypothetical cloud that we have, we have a good reason to think it exists, but no one's ever actually been there or seen it. But it's the spherical cloud of icy rocks that kind of encircles the whole solar system. Exactly how big it is, we don't know, but it could be up to 200,000 times the distance between the Earth and the Sun. And that is in itself almost 100 million miles. So in other words, it could be up to 3 light years big. And what makes it different to the kind of other, because people also talk about the Kuiper belt, which is where other comets come from, which is another sort of region of space beyond Neptune. But what's different with the Oort cloud is it's actually like a spherical cloud, whereas the rest of the solar system just sort of sits on a disk.
So what do we know about this particular comet then?
So this comet was first discovered last year in March by the Zwicky Transient Facility in California, and that was when it passed Jupiter. So now it's at its closest approach to Earth. It's still going to be quite far away, so it's only coming within 45 million kilometers, which is 120 times the distance to the Sun. But this means that, some people suggest that this means that we can see it with the naked eye at the moment. I took my husband stargazing last night to have a look for it, and it wasn't necessarily so easy.
Okay, so where are we looking?
Okay, so it should be near the North Star. So do you know how we find the North Star?
Find the plough?
Yeah, we need to find the plough. So that's the plough up there.
Yep.
And then you find the pointer stars.
So just there,
you follow them up, and then that's the North Star. So it should just be kind of down a bit and to the right of that.
Okay.
Can you see that fuzzy kind of blob?
It looks like there's a ring around it.
A ring around
the North Star.
No, no. It's not exactly at the North Star. It's down to the right of it. It should just be this green-looking blob. At the moment, it's not completely obvious, is it?
No. And there's a car coming, so I can't see anything
that's cute
at all.
looking.
I love that, Abby. You had slightly more success than me because you seem to have seen a green blob, but I tried to see it last night. I couldn't. It was too hazy from my back garden in London. But I do love the idea that the last time it was visible from Earth, there were Neanderthals around that might have seen it. Neanderthal astronomers that might have looked up.
Yeah, they probably had a better chance than we did without any light pollution as well. And actually, I did manage to take a photo on my phone, and I managed to sort of identify it in the photo. But it's really hard to see with the naked eye. I don't know if anyone remembers, a couple of years ago, there was a comet called Neowise that was visible with the naked eye. That was much easier to see. So if anyone's trying to see it again or trying to look again for another comet, this one is a lot harder. After the 2nd of February, which is the closest approach, it's going to be visible for another couple of weeks, but really through binoculars or a telescope. It's really hard to find, especially if you don't have a naked eye view of it. But if you do want to look for it, it's going to be between the Little Dipper, which is the constellation that has the North Star in it, and a constellation called Auriga. But as is often the case, it's really tricky to describe exactly where it will appear. The best way, I think, to really find exactly is to use some software. I really like a free desktop software called Stellarium, which you can put exactly where you live and what time you'll be looking, and it'll show you pretty much exactly where it should be.
Thanks for the tips, but can we talk about the greenness? Why is it green?
Yeah, it's green because it has an unusual form of carbon on it called diatomic carbon or dicarbon. And so what happens is when UV light from the sun hits that carbon, it excites some of the electrons in it. They fall back down, and the wavelength that they emit corresponds to green light.
Very cool. Thank you, Abby. I'm going to try again tonight, and I just hope there's a break in the cloud. That's all for this week. Thanks to our guests, Abby Beale, Carmela Padovich-Callahan, and Matt Sparks, and thanks to you for listening.
Do let us know what you've been enjoying about our shows and also the bonus shows that we've been putting out. You can find us all individually on Twitter or collectively at New Scientist Pod, and do subscribe wherever you get your podcasts. See you soon.
Bye.
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 This podcast is produced by OG Podcasts. Find out more at ogpodcasts.co.uk.